So in this video, we're going to look at tessellations, which is page 35 of the packet. So I'm just going to define tessellations in this video and then do a few more videos about what can tessellate. So a tessellation is an arrangement of shapes or figures closely fitted together, especially of polygons in a repeated pattern, and it has to be without gaps or overlaps. So tessellations occur a lot of times in artwork, or also when you're talking about like in buildings, the tiling on floors is a tessellation, the tiling on ceilings, or like the brickwork outside of houses are all examples of tessellations where you have the same figure repeated over and over without any gaps or overlaps. These were just a few designs that I found. So we have this kind of bird repeated over and over again. They don't overlap and there's no gaps. So this is a tessellation. This one, we have a square. It's just in different colors, repeated over and over again. There's no gaps or overlap. So at any point that you pick on the figure, the shapes all meet there, and there's like, again, no gaps or no overlaps. And same thing on this one. And you can also make a tessellation with multiple shapes. So for this one, it's made up of a lot of triangles, like there's a hexagon. This is like a bunch of triangles together, or you consider a star. So this is also a tessellation. These figures are repeated over and over again. So we're going to do tessellations of polygons. So the first type of tessellation is a regular tessellation, and a regular tessellation is constructed using regular polygons. Okay, and remember, regular polygons means that all the sides are congruent and all the angles are congruent. So like equilateral triangles or squares. And so this is an example of a regular tessellation. The squares are repeated over and over again. At each vertex they meet and there's no gaps or overlaps. And so the point where they all meet we call is a vertex. We also have semi-regular tessellations. And a semi-regular tessellation is a tessellation that uses more than one type of regular polygon. The key again is the angles. The sum of the angles at each vertex must sum to 360. So think about it at a vertex. That's like I have a circle around it, making a circle. And so that point, all the angles have to add up to 360 degrees because it creates a circle. So one example of a semi-regular tessellation would be an equilateral triangle with a regular hexagon, and that's because the angles in an equilateral triangle are 60. So if I draw it on the side, I have 60, and the angles in a hexagon are 120. And then again, if it's an equilateral triangle, this is 60. And then 120. Sorry, this is my horrible drawing. But to show you that if you add these all up, if you add 120 plus 60 plus 120 plus 60, and this gives me 180 plus 180, which is 360. And so at any vertex, it will have to add up to 360 degrees. So a semi-regular, again, is two regular polygons meeting at a point, and those two regular polygons can be repeated over and over again so that we have no overlaps and no gaps. So that's where we're going to stop in this video, and then I'll explain a little bit more about tessellations and how to figure out what tessellates in the next video.